Let's revisit some ideas about probability that you've discussed probably in years gone by. So probability gives, or probability values give the likelihood of an event taking place. So impossible is 0, 1 is certain, 0.5 or a half is in between those two, so like tossing a coin. Note that you can't have a probability greater than 1 or less than 0. And this seems obvious, and many students will sort of go, oh, how could you get a probability more than 1? And invariably in an exam or in a test, a number of students will state a probability of something being either more than 1 or less than 0, i.e. negative. So take note of that, girls, that if you get a probability larger than 1 or less than 0, your answer is wrong. Don't even need to look at it. I know it's wrong. Experimental probability. So what we do with experimental probability, these are probability values are calculated based on data collected from a number of trials or experience. And what we do is we repeat that trial or experiment many times, and that gives us what we call our long run proportion. So in the long term, this is what we expect to happen. For example, the likelihood of a train being late based on past experience. Like you might catch a train and know that the 7:17, it just always seems to be late. That particular train always seems to be late based on your experience. So how late? 3 minutes, 4 minutes. Okay, you can build up an idea of that over the long run. It's not just like yesterday it was late, okay, but over the long run you just know that 7:17, it's always late. So here's an example. An experiment involves tossing 2 dice and counting the number of sixes. Here are the results after running the experiment 100 times. So 0 sixes happen 62 times. Now you'd expect that because on a dice, there's 6 possibilities, okay? So 0 sixes might mean when you roll the dice, you got like a 1 and a 3 for argument's sake. That means you got 0 sixes, okay? So that happens 62 times, that's highly likely. You might get 1 6 and something else, so that might be this scenario where you get a 6 and for argument's sake a 1, or you get the 2 sixes, that is, you get this situation. So 2 sixes come up, okay, in which case it's a 1 in 36 chance theoretically. All right, so this was the experiment that was run. They did it 100 times rolling dice, and what they did was noted that when no 6 came up, they just noted or added 1 to the frequency, okay? All right, so 0 sixes happened 62 times out of the 100 times the experiment was run, which is 31 out of 50. 2 sixes, that's this one here, happened 3 times out of the 100 times. Fewer than 2 sixes, so fewer than 2 sixes is 1 6 and 0 6. So that happens 62 and 35 times, or it didn't happen, or it was not this 3 times, not that, okay? So that means that it was 97 out of 100, okay? Which is the addition of those or removing that from 100. At least 1 6 means 1 6 and 2 sixes. Okay, and that happened 38 out of 100 times or 19 out of 50. So just note that the expectation is that you always simplify your probability. Don't wait to be invited or asked to do it. You'll need to do it. Okay, so now on to theoretical probability. Probability values that are calculated based on known information about the conditions. For example, the likelihood of rolling a die based on the even chance of rolling the numbers 1 through 6. So find the probability of choosing a red counter if a counter is chosen from a box that contains the following counters. So in the box we've got a red, a red and a red, and a yellow, and a yellow. So we're doing the probability of choosing a red counter, and we're noting that there's 3 red counters out of the 6 total red counters. So there's basically a 1 in 2 chance of getting a red counter. Now, does that mean that if I take like a counter and then note its color and put it back in and do that 6 times that I'm going to get 3? Not necessarily. In fact, you could do this 6 times and it just so happens that you would get 6 red counters. Okay, so, but this is the theoretical probability. Remember, theoretical and what actually happens don't line up often unless you do it lots and lots of times. All right, this one here, we got 3 red and 5 yellow. So that's going to be a probability that it is, what color are you looking for? Red equals the 3 red out of the 8, which can't be simplified any further. So a 3 in 8 chance. All right, here's a good question from last year on experimental probability and was done really poorly actually. A dice numbered 1 to 6 is biased. That means that there's a problem with the dice. Well, not a problem with it, but just that particular things are more likely to come up than other things. Okay, so probability of 1 and the probability of 2 and the probability of 3 are all the same thing. So that means that the chance of getting a 1 is a quarter, the chance of getting a 2 is a quarter, the chance of getting a 3 is a quarter, 4, 5, and 6 then is what I'm after. And they've said that we want to show, and they're all the same. So the probability of getting a 4, a 5, and a 6 is all the same. They want us to show that the probability of getting a 4 is 1 in 12. All right, so remember with show that questions, what you've got to do is pretend that they haven't told you the answer. So we know it's 1/12, but what we want to do is find the probability of getting a 4. So we're not allowed to use that information 1/12. So what I know is that this is x, 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 and all of those x's are the same value because they represent the same amount. All right, well, what have we got left? We know that the probability of 1 plus the probability of 2 plus ... probability of 6 must equal 1, okay? When we add all of these individual probabilities together, it has to equal 1. All right, now, what do we know so far? We know that the probability of 1, 2, and 3 is all 3/4. So we want to know what we've got left over to share between 4, 5, and 6. So I've removed 3/4, which is a quarter plus a quarter plus a quarter, from 1 to get a quarter. So the leftover probabilities, or the probability of 4, 5, and 6 all added together, must be a quarter as well. All right, so we've got x plus x plus x must equal a quarter. 3x equals a quarter. X equals a quarter divided by 3, which is a quarter times 1 on 3, which is a 12th. Okay, so what we're going to say is, therefore, probability of 4 equals, because I've just found out what x is equal to 1/12. And it just so happens then, this is when you want to look up, that's what you were supposed to do. You were supposed to show that the probability of 4 was equal to 1/12 as required. You don't need to write that, but that's what I was supposed to do. What is the expected number of 4s showing uppermost in 600 rolls of the dice? What is the expected number of 4s? So the probability of a 4 is equal to 1/12. So I know that a 4 is going to come up 1 out of every 12 times, or a 12th of the 600 rolls. 1/12 times 600. So the probability of getting a 4 for this situation is 1/12 of 600. Now let's simplify that fraction. So we've got 12 goes into itself once, 12 goes into 65 times. 12 times 50, 600, yeah, definitely, equals 50, therefore 50 4s are expected. Now, if it was a fair dice and we had 600 rolls, we would expect 100 4s, but this is a not fair dice or a biased dice. That is why that's not 100, because it's less likely that a 4 is going to come up. Of 1,260 rolls of the dice, how many would you expect to be at least 3? So at least 3 means we want a 3 or a 4 or a 5 or a 6. But it also means it's not a 1 or a 2. So we're not after a 1 or a 2. So it might be actually easier if we work out what the chances of a 1 or a 2 were, and then do the reverse of that. So let's have a look at a 1 is going to be a quarter. A 2 we already know is going to be a quarter. So a quarter plus a quarter is equal to a half. So the probability of getting a 1 or a 2 is a half. And that means that the probability of getting a 3, 4, 5 or 6 also must be a half. We don't need to, but I'm just going to confirm that by going 3 was a quarter, 4 was a 12th, 5 was a 12th, and 6 was a 12th. All right, if we add them together, we've got 3 twelfths, which is equal to a quarter, and we've got a quarter as well for 3, so a quarter plus a quarter also equals a half. So these 3 added, or these 4 added together equal a half, but it's easier to do that, not these two, okay? So what I'm going to do is say, what is a half of the 1 to 1,260? That's a half times 1,260. 1, that's going to be 630 equals 630. So expect 3, 4, 5, or 6, 630 times. Okay, there's the work for you. 8A, please, girls.